All right, guys, so protein synthesis. This is something that is very important because proteins are what we see, like the physical manifestations are DNA. So mRNA contains a sequence of codons, we talked about that, which determines the order of amino acids. Order of amino acids determines protein. tRNAs bring specific amino acids to the peptide chain. rRNA contains building sites to provide the platform so the protein synthesis can happen. An anticodon, 3 amino acids, and tRNA complementary to the codon in mRNA. Like, there's a whole lot of stuff going on here. But don't worry, it's not too bad. All right. So the way that this works is we have our mRNA, our three, this is one codon, and that codon is UCA. That means our tRNA brings specific amino acids to the peptide chain. Our tRNA has AG and U on it. Okay, so it's the opposite. That AGU from this tRNA tells your body to bring a serine amino acid to it. Everybody understand that? That's like the whole thing. It's kind of wild. But this right here, this tRNA, that is going to be the piece that allows us to build polypeptide chains. So in our initiation, we have mRNA binds to ribose, great, and tRNA carries the first acid to the building site. Awesome, way to go tRNA. Elongation, this makes sense. Things get longer, we're building that polypeptide chain. Protein synthesis occurs in two adjacent sites on the ribosome, no big deal. And then termination, that's when we get a stop codon. And when we get a stop codon, that protein stops getting. So here you go. This is kind of like, this is the whole shebang right here. All right. I realize it's kind of small, so I'm going to make this big right now so that we can see what's happening. Whoops. Sorry. So we can see what is happening. Here you go. You start here. All right. So you have your codon, your anticodon, your tRNA, and then your amino acid. All right. So then the next codon comes up, which is an anticodon, which tells the tRNA to bring a specific amino acid. Then we have elongation, and we get the same thing happens again. No big deal, right? And what you end up getting is this big long chain of amino acids, and that is how we build proteins. And it's going to do that until you get a codon that tells you to stop. So that's how we build how we look like, which is kind of exciting. Sorry, I got to refine my spot here. All right, so that is what's going on. And if you look at slide 23 here, this is kind of a big to-do. All right, so we have our informational strand, blah, 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 our template strand, which is very easy to put together. Our mRNA strand starts with a 5' here, and we get this particular thing here. And so we break it up into 3 amino acids. That's why, or excuse me, 3 bases. That's why we have these little chunks for our codons. And so here, this is our end right here, mRNA. These are anticodons, and these anticodons bring these specific amino acids, and voila, we have construction. All right. I've done the same thing here. You can follow right along. All right. I've just made, a different chunk of DNA. It's not that big of a deal. Info strand, template strand, your messenger RNA, your tRNA, your anticodon, and that brings the specific amino acid. There we go. That's how we build stuff. Mutations. Everybody wants to talk about the X-Men here. You can read through this. There's a bunch of different types of mutations. One that's important is a silent mutation. Codon is a place with a codon that codes for the same amino acid. So like, doesn't really make a difference. So like a point mutation, here there's several. Here's our original, and the point mutation, one of these bases changes, which is going to change what sort of protein you make. Deletion, where one goes away, so you have 6 bases and now you only have 5. And then there's an insertion where something gets popped in between 2. So GAG, then you get a C placed in here, which again changes what's happening. So here, a silent mutation, we have D, here's our DNA, here's our mRNA, which gives us this amino acid. The mutation is CTC now. However, that gives us GAG as our mRNA. That brings us the same amino acid, so we don't have to worry about it. There's no change in protein synthesis. That's why it's called silent mutation. Here, we start to end up with like a problem. This could be a big, here's our original CTT, and the C gets mutated to A as a point mutation. You get this, that's a stop codon, which means you stop producing the protein. This is where things can get very difficult. Some cancers are associated with sort of stuff, and so this becomes a very big problem.